Our mission on this quiz was to be able to figure out how to make 3 solutions. One of them was going to be made from crystals. That means that it's going to be in grams. The other 2 were going to be made by using solutions. That means they are something called a dilution. The first one was a crystal one. Now, before I even start doing this, I'd just like to draw what it is I'm trying to accomplish. This says I need 250 milliliters of a 1.5 molar solution. How am I going to do that? Well, one of the ingredients will be water. I don't know how much yet. The other ingredient will be some sort of crystally salt. It's LiCl. LiCl. I don't know how many grams of that stuff that I'll need yet. When you're doing crystals, crystals dissolve. They don't take up extra space. They fit in between. So when it says you're going to make 250 milliliters, at this point we can say it's 250 milliliters of water because when you add crystals, they dissolve. They'll fit right in between the spaces. The next thing we have to do is to figure out how many grams of crystals. It's based on this formula. Let me go back a page. This formula says that molarity equals moles divided by liters. I like it as a round little buddy. So I'm going to just recreate my big M, little MOL, and liters right here. Molarity is equal to, molarity is moles per liter. Well, I need grams. Nowhere on there is grams. The closest thing, though, is moles, if I could figure out moles. So I'll cover up the word moles. This tells me to take molarity times liters. Molarity that I have to make is 1.5 molar. Liters I have to make. Next step. I didn't make up this formula, but I have to follow it. Since it says that the definition is moles per liter, I have to change this to liters. So even though they told me 250 milliliters, I have to move the decimal over 1, 2, 3 to get 0.25 liters. 1.5 times 0.25 equals 0.375 moles. But that's not what they wanted to know. They wanted to know grams. 0.375 moles of lithium chloride. What you have to do is you have to figure out how much 1 mole weighs so that you can multiply. You got to look up lithium on the chart. It's 6.9. You have to look up chlorine. It's 35.5. Add those together. I don't know what it is. Is it 42.4? 42.4. 42.4. 0.375 times 42.4 equals 15.9 grams. 15.9 grams. That's what goes here. You have to take 15.9 grams of crystal, add 250 milliliters of liquid, and you will have 1.5 molar solution. What's next? The next thing is we're going to use that stock solution from number 1, this stuff, 1.5 molar, and we're going to dilute it in such a way that we have 800 milliliters, but the new strength has to be only 0.5 molar. That's less than 1.5, so we're going to be diluting it. What's the ingredients? We're going to need some water. We'll have to figure out how many milliliters. In this case, we don't need any grams. We have to figure out how many milliliters of this stuff, 1.5 molar lithium chloride to add in. And so this is different. I can't just write 800 at that area because we're adding 2 liquids together which add together. So this is a different formula. This is the dilution formula. M1V1 equals M2V2. I like to think of this as the stock is whatever we're using to make it, and the new one is whatever we're trying to make. What's the stock that we're using? Well, we just said it was this stuff, 1.5 molar. How much of it? That's the burning question. We need to figure out what volume. When we're all done, what kind are we making? We're making 800 milliliters, and we're making it 0.5 molar. Somebody last hour said, Mr. K, how come you use milliliters here, but last time you used liters? Up in this one, I had no choice. The formula says liters, you're stuck with liters. That's by definition. But down here it says M1V1 equals M2V2. It doesn't care what your volume is. You can have it in whatever. Just realize that if you start with milliliters, you're going to be figuring out milliliters. Next step. How do I get V1 alone? Divide this by one, whatever it's over, which is 1.5 molar. That'll cross off. But what you do to one side, you have to do to the other. 0.5 times 800 divided by... That'll sound good on. Is that one 267? Yes, I'm going to go 267. How do I know it's milliliters? Because this and this crossed off, so I don't have to use the other one. 267. Okay, here's a tricky part then. Since I need 800, but I already put in 267, 800 minus 267 is going to equal 533. 533, that is not a 533. Last one. Next one. This one clearly tells you, got to read carefully. It says use the same one from number 1. Very different than some of the practices we did. But using your stock solution from 1, calculate how to make another dilution. All right, so what am I making? Start drawing a beaker. It's got to be 50 milliliters. That's not very much. It's only got to be 0.05 molar. That's not very much. I'll be using water as one of my resources, and I'll be using the stock solution. Still, this stuff, 1.5 big M is still what I'm going to be using, and the burning question is, how many milliliters of that do I use? I use the same formula, the dilution formula. The solution I'm starting with is 1.5 molar. I'm trying to figure out how much of it I need. The solution I'm ending with is 50 milliliters, and it can only be 0.05 molarity. How do I get V1 alone? By dividing by 1.5 M. What I do to one side, I have to do to the other. 0.05 times 50 divided by 1.5 equals, wow, that's only 1.67 milliliters, or 1.7. I'm just going to round a little bit. That's only 1.7 milliliters. All the rest has to be water. How much is that? 50 minus 1.7 is going to be 48.3-ish milliliters.